Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled, What are Stellar Cores? Now, stellar cores are celestial objects belonging to a large system of objects that have invaded our solar system. These objects have been extensively observed in the sun's corona and often in the process of making a matter connection with the sun. This connection is in the shape of a vortex. Their gravitational interaction with the sun and other celestial objects is weak, so that they may be as large as the sun but interact as if they have the mass of a very small moon. The interaction through which they draw matter from the sun is tidal in nature. They are, however, powerful objects with a very powerful ability to draw energy from the sun. They do not emit visible light when they first arrive in the sun's corona. They may, however, emit infrared radiation at that time. But after drawing energy from the sun for some time, they are able to emit radiation in several wavelengths, namely X-ray, ultraviolet, and visible light. They are, however, never brighter than the sun, as the energy they gain, which then allows them to emit light, comes from the sun. The fact that they are X-ray sources is one of the ways that it can be deduced that they are stars. They are stars that once emitted light, like our sun, but have run out of energy and died. They are dead stars. They are dead because they can no longer generate energy in their cores. They can regenerate up to a point by drawing energy that the sun generates from the sun or other planets in the solar system, but they cannot regain the ability to generate their own energy. This means that they remain dependent on their host body and are thus never likely to withdraw from it. And we see here one of these objects. This one is dark, and it's making this matter connection with the sun, which is in the shape of a vortex. It's making its connection with the sun. It is in the sun's corona. It's a dark spherical object. And this is an STO image in 171 angstroms from October 13th, 2017. So this object is not yet able to emit ultraviolet light in this wavelength, and this is why it looks black in this image. Now here we see some more of these objects. This is one of these stellar cores, and also in the sun's corona, although a little further away from the surface of the sun. And then in comparison with where this object is, this one is extremely close to the surface, making its connection there. And this one also seems to be a little larger, perhaps 1/5 the size of the sun. This is one of the smaller ones, perhaps 1/6 the size of the sun. This, on the other hand, is a very large stellar core. It was also seen within this CME, and soon after the CME was ejected by the sun. So we know that it was very close to the sun, so we can make a size comparison between the object and the actual sun. And the size of the sun is indicated by this white circle on the occulter. And this is a LASCO C2 image. The cactus images are also based on LASCO C2 images. But as you can see, this object is about the same size of the sun. So this is a huge object and very close to the sun. And here is another one, and this is another smaller one, and we can see that it's striped. The stripes follow the contours of the object. Obviously, it's a spherical object, and we can see that there's some kind of trail behind it, which indicates that it's drawing material from the sun's corona. And this one is emitting ultraviolet light. This is why we can see it in the computer-generated color of these images. This is an STO composite image. And the object must be emitting ultraviolet light to be seen in this false color generated by the computer, but which shows that it is emitting ultraviolet light. Now, this is the 2007 stellar core. One of the first times I actually observed one of these objects going into the sun's corona. And we know that it goes into the sun's corona because of the red coloring it has. And this red coloring tells us that there is light emission from the sun's corona. As you can see, we see this red light emission, and this is a ultraviolet light in 304 angstroms wavelength. So we know that there is light emission between the detector and the back of the object, so we can see that the object is in the sun's corona, and we can actually see, if we look at it carefully, that here it's entering the corona. That part of it is dark because it hasn't entered, so there is no light given off by the corona from this section of it. And of course the corona makes a shell-like shape around the sun, so further out we can see the light behind the object. And we can see that this part is still in darkness. We can see the same thing as it exits the corona. Part of it is still inside the corona, part of it is now outside. We can see it starting to exit over here. So we know this object was very close to the sun. We know how long it takes to traverse the sun. And we can do a size comparison between it and the sun, and it turned out to be about 2.2 times the size of Jupiter. As you know, Jupiter is a huge planet in our solar system. These are absolutely huge objects, but the speed at which it traversed the sun was 39 kilometers per second, or 24 miles per second, and this speed is much lower than the sun's escape velocity, and this indicates that it has a very weakened capacity to gravitationally interact. And I've written about this in several articles. You may look at article 153 entitled Planet X, Escape Velocity and Gravity, and article 210, Stellar Core Gravity, Tidal, and G, the gravitational constant, is not constant. So the name stellar core comes from my observation that these dead stars have solid surfaces, and that even the material clinging to the surface, which gives rise to their often striped appearance, appears to be solid but clumpy. These observed surfaces seem to be what is left of a star, and it looks like a dense and solid core, and hence the name stellar core. The stellar cores share the material making up their outer layers when they arrive in the sun's corona, and appear to then gain a new outer layer and atmosphere from the sun's corona, or from whatever other object that becomes their host. There is evidence that the Earth is also hosting some of these objects, and you may look at article 227 entitled Stellar Cores Affecting Earth and Possible Connection to Volcanic Eruptions. Now, so this, after observing this called the blue stellar core, this is why I deduced that they were solid objects, and these are actually the cores of what's left of what was once a star that emitted light, much like our sun. And as you can see, grooves in the solid surface.